Welcome everyone. This is a demo about the Risk Assessment and Optimization Framework, in short RAOF, a component of a MEDINA platform. And my name is Artyom and I'm going to describe how our component works. The outline of the talk is very simple. We start with the overview, show how to use our component, couple of words about the installation, and further information. In the middle, I'm going to show you a demo in order to demonstrate how our tool works. We start with an overview. The main goal of risk assessment and optimization framework is to provide a risk-based analysis of non-conformities with EUCS for cloud services. We would like to underline that every cloud service provider must perform its own risk assessment, as it is actually written in EUCS, and any security guidance, and actually that's the logic of any good cybersecurity practice. So our tool, although it performs the risk assessment, does not have the goal to substitute this kind of analysis. It can be used for this purpose if it's found appropriate, but we do not have a goal to substitute that. The goal is to provide a risk-based analysis of non-conformities. So that's why our risk assessment tool actually supports certification evaluation process against the selected certification schema, which is EUCS in this case. It is set up and it has the main focus for cloud, and all the threads that we selected, all the resources that we considered are cloud specific. It can be used manually and automatically. Manually, this means that information, the input for the tool to operate, is provided by an operator directly through the graphical user interface or through a specific dashboard, and in this case using the API of our component. Automatic analysis assumes that there is a monitoring tool or a set of monitoring tools that perform the monitoring and then tell to our component which of the requirements is satisfied and which is not. Finally, our tool also has the support for optimization of the future effort to ensure compliance, just to help the analyst or compliance manager to plan its effort in case the service is found to be non-compliant. Said this, I would like to underline that our tool can be used in two phases. First, let's call it bootstrapping phase. So at this moment, the CSP is preparing for certification and would like to understand whether its system, its cloud service, is ready to be certified. So certification is not yet obtained. The fulfilled requirements have to be described and provided to our tool for the analysis through a dashboard or by an operator through the graphical user interface. The tool performs the analysis of non-conformities and tells whether the detected deviations, if any, are major or minor, and also can help the operator to plan future actions by optimizing the effort if some additional parameters are known. We will talk about this later. Bootstrapping phase exactly is the phase that this presentation is focused on. The second phase is the continuous monitoring phase. So certificate is already obtained, and the tool and actually the whole MEDINA framework performs the analysis, the continuous analysis, whether this certificate should be maintained or revoked. So it is based on the measured metrics. So our analysis is based on what have been objectively measured by our monitoring tools, and the information is provided through the API. So goes the output, which is actually non-conformity assessment, which is done in a similar way as it is done in the first phase, and the output is provided to further in the chain of MEDINA workflows for the further management, to the lifecycle manager in particular. And of course, such kind of operation is useful for the dynamic monitoring, in contrast to the first phase. If you're interested in how the second how our tool works in the second phase, please see a dedicated video about the continuous monitoring phase that is related to the work package 4 of the MEDINA project. This is the general diagram of components of MEDINA. Our component, risk assessment framework and optimization framework, is on the top, is the most top left component, and those interactions that are marked with red arrows belong to the bootstrapping phase, and those interaction marked with blue arrows leading towards and from this component belong to the continuous monitoring phase. So we can see that our component interacts with the dashboard, the most bottom right component on the picture, and the catalog of controls and metrics. And during the monitoring phase, continuous certification evaluation provides the data, the input about satisfaction of the current state of the requirements to the RAOF, and the RAOF reports to the lifecycle manager, reports the decision. So in more details, we already said that our tool interacts with the user through the graphical user interface in order to conduct the risk assessment. So a user provides the data and gets the output. And similar thing for risk optimization. Provide data and get the output. The very same operation could be done through the dashboard using the API. Catalog of controls and metrics has its own questionnaire in order to collect the information about satisfied requirements, similar to our questionnaire. In order not to ask user to answer all these long questionnaires twice, we have the possibility to import the values, the information from the catalog of controls and metrics. So once a user fill in this questionnaire, after pressing a button, this information could be transferred to our tool. Continuous certificate evaluation is used by RAOF in order to get the measured status of requirements and perform analysis, and then send the non-conformity assessment result to certificate lifecycle manager. Now we go a bit more in details how our tool work, and then I'm going to show you the demo of the tool. To clarify, we use a self-assessment tool for risk analysis as a tool that implements functionalities of the risk assessment and optimization framework. So SATRA is just a tool implementing RAOF. It is implemented, SATRA is implemented as a service. It allows fast and simple cyber risk assessment for cloud service provider. The Key point here is that it's fast, simple as and actually it relies on it doesn't require a lot of knowledge of cybersecurity um, and how to perform risk assessment. It must be fast and simple, especially for the continuous monitoring phase, right? And it requires very limited amount of information that have to be provided by a user or monitoring tool, which are the following: addressed security requirements, so which requirements listed in the UCS have been addressed and which one not, and the main assets or resources of the cloud that in question. Our tool is actually based on a certification scheme. In particular, in scope of this project of MEDINA, we focus only on EUCS, so all the requirements come from the UCS, but it can be extended to other standards like C5, Signum Cloud, or ISO 27000 standard, the dedicated one, or the one that's 001. In a nutshell, how SATRA operates. It, so as any risk assessment tool, it gets three main components: threats, assets, and vulnerabilities, and then aggregates this information in order to calculate the risk. Threats, um, in our case, are encoded in the tool. So it's a list that is already contained in the tool. Since we know that we talk about cloud, so we have, from our perspective, an exhaustive list of all possible threats. So the user should not take care about that. And those threats that are not relevant will be just simply ruled out in the analysis if found irrelevant, right? Assets, or the resources of the cloud, are known only by the owner or the operator of this cloud and have to be provided by them. As for vulnerabilities, in scope of our analysis, a lack of implementing a requirement from a certification scheme is considered a vulnerability. So it's an open way for an attacker to penetrate into the system. That's why we need the information about those requirements that have been implemented. The process, the risk assessment itself, is automatic, and it combines the frequency, the expected frequency of the threat, the impact value of the asset, and the um, success or survival probability of a threat. The result is the real risk value. So what is the expected risk for the cyber risk, of course, for this specific cloud service? Then we compute the non-compliance evaluation. Recall that this is our main goal, is to not to compute the risk, but um, to evaluate non-conformity. How it is done? It is done in the way that we first we compute ideal risk, so the risk in case all requirements are implemented correctly for this specific service. The difference is then compared with the threshold. If the difference is higher than the threshold, so we say that the deviation is too high and we have major non-compliance. If it is lower, then we say it's minor, and now it is up to the auditor to decide how to deal with that. But what to do if the service is found non-compliant, so major non-conformities are detected? There is this supporting tool that could help a compliance manager to identify those of the failed requirements which can improve security in the most cost-efficient way. So Of course, it would be nice to implement everything, but if the budget is limited, then there is a question is how to optimize the investment. What is required for this kind of analysis? The assessed risk in the way it is done previously. So we saw how to do it previously. Cost of the failed requirements, so to understand how much would it cost to the CSP to implement those of the failed requirements, and the budget that is available, and then the analysis is performed in order to optimize the expenditure of this cloud provider. The output of this procedure is the selection of requirements to be implemented and the updated risk value, as well as a non-compliance gap or result. At this point, I will switch to our demo and show how it works. Finally, let's see the tool itself. After logging into the system and selecting a risk assessment, it is possible to see all the supported services that have been added to the system. At the left, we can see the IDs, but since the IDs are illegible for humans, so there is also the name of the considered service that could be written as the user like. And once the appropriate service is selected, it is possible to start working with that. First, it is required to add the information about the kind of the cloud service. So what kind of service we have, for example, SaaS service. Select the certification schema, which is only UCS at this moment, and the assurance level, for example, high. Then it is important to say whether we are preparing for the dynamic risk assessment or would like to conduct the static risk assessment. At this video, we focus only on the static risk assessment only, so we select this option. And immediately, we are prompted to provide information about fulfilled requirements. As you can see, all the EUCS requirements are listed here, and the user must answer whether the corresponding requirements are implemented or not. It is possible to say that they are partially implemented, yet it is still will be considered as not fully implemented requirement. And not applicable in rare cases. Of course, this option has to be confirmed with the auditor that it is indeed not applicable. So in this case, it will be considered as not applicable requirement for the analysis and will not affect much the computation. The user should pass page by page, implementing all requirements. So we can see that we have 20 pages of requirements. All UCS requirements have to information about all UCS requirements has to be provided. We are not going to do this in this video, but you can see that all main category, so one page is dedicated per category. At the very end, the user will be prompted to provide the information about assets. Assets are provided through the following table. A user should add as many resources as available, yet it's not obligatory for the user to add all resources if they are of more or less the same kind. For example, if there are two databases that do not contain much of important information, so we may simply say there are two databases. Then two values confidentiality, integrity, and availability level of loss that is expected in case database is compromised, so is provided. We would like to underline that there is a somehow rules of thumb that should help to identify which of the levels is appropriate, and it must be set up. Then we have to press twice just to be sure that we are done. All information is provided, and the tool will do the analysis itself. Well, clearly here, the first thing we can see the radar chart that shows how well all categories of EUCS are implemented. So they all must be one in the ideal case, but we can easily see here that there are some problems with organization of information security and business continuity. The computed risk, this is the real risk, and this is the best risk value that is possible to obtain if all security features are implemented, all requirements are implemented. Note that this value should not be zero, because risk, no matter how many security features are implemented, how well your security is, there is always a possibility to penetrate into your system, and if you have important and valuable assets, they could be compromised. So risk will still be there even if you implement everything. Yet you can see that this risk is lower than the one that is expected if the current configuration of security is maintained. Non-conformity gap, this is the value, and it is still considered as major gap. There are some values, the expected monetary losses for each supported threat that is available to the analyst, so the analyst could identify those threats that are most important for this service. But what is the most important here is that right now we see major non-compliancy, which means that it is hardly that this service could get the certificate. So what should the CSP do in order to improve its state? So clicking by suggest optimization, they could get the support. This is not obligatory tool. This is something that the user could use in order to plan its effort. For example, if the budget is probably 3,000 and every of the failed requirements, so we have 5 requirements that have failed, costs 1,000 euro to implement, then our tool will find the best way to spend this money, saying that you can see the first, the fourth, and the fifth requirements have to be implemented. In this case, risk will drop to this value, and the non-conformity gap will be much lower. Moreover, what is more important is that in this case, the non-conformity gap will be considered as minus. So even though these two requirements are still not implemented, the expected risk is considered to be, the deviation is considered to be minor. That's it. Thank you very much. Now, a couple of finalizing comments. First, about installation of our component. RAOF is implemented as a Docker component, so it's actually composition of several Docker components, and it is required to use the Docker Compose to execute and deploy the graphical user interface, API, and the rest. So there are actually 4 containers that contain these components of our component. The main engine that contains the risk assessment module as well, the risk based decision support and the graphical user interface. Another container is specific for API. The third one is for the database that contains data, and the risk optimizer has its own fourth container. A couple of words about the technical specification. The tool is implemented using mostly Java with the Spring Boot 5 framework, with some parts implemented in Python. It runs over Tomcat 8 and is running over Apache 2 web service. It uses MySQL database for data storage, and it needs Docker Compose for installation, as it was said before. The further information, so actually that's it about our tool. Here's some links for the project. If you're interested in reading the deliverables, watching the YouTube channel of MEDINA and find more information, GitLab, Zenodo, and so on. I would like to thank you for your attention, and hope you will find this information useful as for our component as well as for the MEDINA project in general. Thank you very much, and goodbye.